I'm Skye Marthaler. Welcome to another episode of Rooftops of the Solar System. Today, we find ourselves in a new realm, the domain of the gas giants. But before we embark on this adventure, take a moment and click that red subscribe button below and the bell icon next to it for all the latest Rooftops of America and Rooftops of the Solar System updates. Today, we visit the king of the planets, Jupiter.
In the heavens, Jupiter reigns supreme.
In our solar system, there is one planet that stands above all the others. It travels through the system dictating events, a gatekeeper, warding off threatening objects, its presence providing the stability needed for life to take hold. That planet is Jupiter, the largest in our solar system. If you were to observe our solar system from across the galaxy, you might arrive at the conclusion that our little yellow star has only one companion, a gas giant, orbiting around it around 475 to 500 million miles away, which may strike you as a bit unusual, being that far from its star. Jupiter is the third brightest object in our night sky, and like the other visible planets, has long captivated humanity's imagination. For one thing, it's easier to spot than Venus, higher up above the horizon, and staying visible throughout the night. Its movement throughout the sky is where we get the Chinese zodiac from. The ancient Chinese broke up Jupiter's orbit around the Sun into 12 equal sections, one for each year of its journey. Other cultures put their own identities on it as well. The Babylonians named it after their god Marduk, and were the first to record their observations of it. In Greco-Roman culture, the Greeks named it after Zeus, the Romans Jupiter, the god of thunder and ruler of the heavens. Jupiter is a fascinating place. It stands almost straight up and down its axis with a declination of only 3.1 degrees. And it rotates on this axis a bit less than 10 hours, the fastest of any planet in our system. And it weighs an incredible 4.184 octillion pounds. That's 27 zeros. Trying to explain something the size and weight of Jupiter can be a bit of a challenge. Planet-wise, there is really nothing like it in our entire solar system. It is big, really big. So we're going to do a little demonstration to sort of help show the size of it in comparison to other things as well. Our sun, which is also big. Take this apple. Consider this the sum of everything in our solar system. Now, the majority of this apple is our sun. And so go. Now, that's our sun. This is everything else. Now, half of this is Jupiter. The remainder is everything else. You can take every single other planet, the asteroids, the comets, all the debris, and pack that all into Jupiter. and still have room to spare. As you may expect from something so massive, Jupiter, more than any other planet, dominates our solar system. How it formed, how it looks right now, and how it will be in the future. It is the master of the planets, its gravitational influence effectively splitting our solar system into two parts, the inner and outer. And at times, Jupiter can be both defender and destroyer. For Earth, Jupiter effectively serves as a giant shield, protecting us from any rogue elements, comets, or other debris. In fact, its amazing gravity has gained it the nickname, the vacuum of the solar system, quite literally sucking in anything that gets close to it. One of the most famous examples was the impacts of the comet Shoemaker-Levy 9 in July 1994, the first observed impact of extraterrestrial solar system objects. Over the course of 6 days, the 21 objects of the broken comet crashed into the planet at a speed of 37 miles per second. More recently, images were caught of an asteroid smashing into Jupiter. Overall, it is theorized the planet absorbs anywhere from 2,000 to 8,000 times more impacts than Earth. The stability that Jupiter brought to the inner solar system is even theorized to be one of the reasons why life was able to establish a foothold on Earth and eventually thrive. Without the gas giant's incredible gravitational pull drawing in any dangerous objects, it's safe to say we might not even be here. Jupiter has also played a critical role in Western science and astronomy. In 1610, Galileo turned his telescope towards it and turned the world upside down. But more on that in just a bit. Now let's fast forward 360 years. In the early 1970s, Pioneers 10 and 11 were the first space probes to visit and photograph Jupiter, giving us an up-close look at the planet as they flew by, and along the way making some key discoveries, such as the planet's intense magnetosphere and the fluid nature of Jupiter's interior. The next two space probes to reach the planet are legends, and one of them will be our companion for the next 4 planets. The Voyagers both flew by in 1979 and were able to make some fascinating discoveries of Jupiter and its 4 large moons. The first probe to enter orbit around the planet was Galileo, arriving in 1995 and studying the planet for the next 8 years. Well over a decade later, the Juno orbiter would arrive, and as of 2020 is still currently in orbit around Jupiter. Here's a fun fact. Jupiter is the most visited of all the planets in the outer part of the solar system. Its gravity allows any spacecraft heading to the outer reaches to save both time and fuel on its journey. It also works really well as a test bed for any ground crews back on Earth, allowing them to make checks on equipment before the probe reaches its final destination. Jupiter is a gas giant and primarily made up of the first 2 elements, hydrogen and helium. It is the largest planetary atmosphere in our solar system. But it gets more interesting than that. Jupiter is also home to the largest ocean in our solar system. And deep at its center, it is believed to have a solid rocky core. For prospective astro pointers, though, it's going to be a case of look, but don't touch. You can't really high point Jupiter. Even if you could, let's say, get down to its theoretical solid core, you wouldn't really find any elevation to speak of. Down there is actually thought to be one of the weirder places in our cosmic backyard. There's so much pressure that the hydrogen is liquefied, and it's actually thought to act more like a metal with electrocharges pulsing through it. But that's all moot anyway. You'd be wiped into a pulp before you even got close to it. While you can only observe it, what a sight it would be up close, with its bands of swirling clouds, spots, storms, and aurorae. The bands and spots are made up of ammonia ice, ammonium hydrosulfide, and other trace elements. And the colors are thought to derive from the interaction of heavier elements churned up into the cloud layer from below. As you gaze at it, one place will easily draw your eye: the Great Red Spot, a feature on the planet that has long captivated astronomers and stargazers. This massive storm has been swirling over the planet for hundreds of years. The largest storm on Earth ever recorded measured over 1,000 miles across, and it had winds gusting up to 200 miles per hour. A storm that size would have covered a good deal of the eastern United States. But compared to the Great Red Spot, that would be like us holding out and staring at the head of a pin. The storm is twice the diameter of Earth, making this maelstrom the largest storm in our entire solar system, with the winds reaching up to 400 miles an hour. Because there is no real surface to the planet to weaken it, the Great Red Spot continues to rampage unabated. As captivating and interesting as Jupiter's belted bands of clouds are, they're not the reason we're here. Our interests lie elsewhere in this system, in particular with the objects rotating around the gas giant. As of this recording, Jupiter had 79 moons, the second most of any planet in our solar system. Jupiter's moons are a varied bunch. Most of the moons of Jupiter are small, about 60 of them with a diameter of just over 6 miles or less, orbiting the planet in a complex dance, a solar system in miniature. These smaller moons, they haven't really been documented or explored in any great detail. That said, we do know some things about them. We know the ones that are closest to Jupiter help provide the dust for the planet's rudimentary ring system. The largest of the irregular moons is Himalaya, an object with a diameter of about 86 miles. It is the largest planetary moon that hasn't been imaged in any significant detail. Of the remaining ones, 4 of them stand apart, significantly larger, planet-sized really, some of the largest moons found in our solar system. Once again, to put this into some sort of perspective, these 4 satellites take up over 99% of the material orbiting Jupiter. These are the Galilean Moons: Callisto, Europa, Ganymede, and Io. They're called the Galilean Moons in recognition of Galileo, the astronomer and scientist who first announced them to the world. In 1610, when Galileo turned his telescope to Jupiter and charted the paths of these moons, he upended thousands of years of thought and helped launch a scientific revolution. It truly is one of the defining moments in the history of science. Interestingly enough, Galileo wasn't the first to note this. A German astronomer, and one of Galileo's rivals, had independently made the discovery approximately a month earlier. Unfortunately for Simon Marius, Galileo published his findings first and would receive the lion's share of the credit. But Marius, in a way, did get the last laugh. The moons were eventually named 2 centuries later, with the names that he had assigned them. The observation that these moons orbited around the gas giant was one of the final nails in the coffin for the Ptolemaic geocentric view of our universe. Here was definitive proof that not everything in the celestial heavens orbited around the Earth. And it's these moons where we're going to focus our high-pointing and exploration efforts. It's also the start or restart of one of our lists for our grand tour. In addition to our high-pointing efforts and climbing the 10 tallest peaks in our solar system, we're also going to add on visiting the 10 largest moons in our solar system. Now, technically, we started this with our moon in the pilot episode, which is number 5 on the list. But now, it starts in earnest. And while it'd be nice to say that we're going to climb the 10 highest points on the 10 largest moons, as you'll see, that's easier said than done. There's a good deal about Jupiter's moons that just isn't known. Scientists are putting together a more detailed picture of these moons, even going through data gained from Voyager and Galileo, let alone the current Juno mission. They're uncovering more information all the time, and what we do know has provided some tantalizing clues about the makeup of these worlds, and revealed new mysteries. One of the reasons we have this gap in knowledge is because, as we've established on earlier planets like Mercury and Mars, is that space exploration isn't easy. It takes time and money. And in the case of Jupiter, you have to launch in a certain window during its revolution around the Sun. The flybys that we do have of these moons have been limited, and none of the probes really had dedicated mapping tools to measure the detailed and complex terrain that you'll find. So for us, we've had to make our best educated guesses on this. And there is another thing that we've done so far, but we're not going to be able to necessarily continue. And that's finding the low point in this system. Because frankly, we don't know where it is yet. As you probably expect, there is going to be a whole heck of a lot of challenges in high-pointing the Galilean Moons. And one of those challenges is actually the makeup of the moons themselves. We're now at the point in our journey where we have crossed what's known as the frost line. And that's the area where water remains frozen, even when exposed to direct sunlight. The first 3 moons we'll be visiting are the icy ones, mainly water ice. And while this is good fortune in the quest for extraterrestrial life, it's not as conducive for finding mountains and high points. But once again, we're getting just a little bit ahead of ourselves. If you're looking for water in our solar system, then the moons of Jupiter would be the mother lode. Take Ganymede, for example. It's thought to have more water than all of Earth's oceans. And that's nothing to say about Europa or Callisto. What's really interesting, though, is probably a good chunk of it is actually in ice. And what's truly fascinating is the nature of that ice will change its character as you start in the outer reaches of the Jovian system and move inwards to Jupiter itself. Way out on Callisto, it will be crystalline in nature. But by the time you get to Europa, the ice will have changed to be more amorphous. Regardless, break out your crampons and your ice axe, because for most of our journey through the Jovian system, you're going to need them. There is one big advantage that you're going to have when exploring the Galilean Moons, and that is in the way of gravity. And despite their size, they really don't have much. On the low end is Callisto, at only 12.5%, and on the high end is Io, with only 18%, comparable to our moon. As you'll find, though, you're going to need every edge you can get. We'll start our high-pointing trek furthest out on the moon Callisto. It's the second largest of Jupiter's moons and the third largest in the solar system, with a diameter just shy of 3,000 miles, a bit smaller than the planet Mercury. It orbits 1.17 million miles from Jupiter and travels around the planet every 17 days. Despite that distance, the gas giant's incredible gravitational pull has tightly locked the moon. The icy moons of Jupiter are going to be the coldest worlds that we've explored yet. And they serve as a nice introduction to the more frigid parts of our solar system. In addition to the chill, we also have to deal with minimal atmosphere and radiation, but not from the sun. But Jupiter, the gas giant, puts out enough radiation that if not properly protected and shielded, could have quite deadly results. With all those challenges, Callisto will be the ideal place to start our adventure. It shall be perhaps the easiest of the Jovian moons to explore. Long overlooked, this speckled ball of dark and light spots has been considered a dead world. And looking at its pockmarked and scarred surface, it's easy to see how astronomers arrived at that conclusion. This dark moon is the most heavily cratered object in our entire solar system, the result of being in Jupiter's gravitational focus. In other words, quite literally, in the line of fire. That said, Callisto's surface, despite all these collisions, is thought to be sort of like a time capsule. It's incredibly ancient, over 4 billion years old. And any exploration here would allow scientists to gain a glimpse of that ancient time period in our solar system. For prospective astro-pointers, Callisto has several advantages. For starters, it's far enough away that Jupiter's unrelenting gravity doesn't have as much influence, making it geologically stable. It's also outside of Jupiter's powerful magnetosphere, meaning it escapes the harmful radiation from the planet. And on top of that, as mentioned before, you'll get a gravity benefit as well. One of the challenges that we may find on Callisto has to do with its, let's call it a secret, though the cat may already be out of the bag, because recently scientists have theorized that Callisto may have liquid water. It's just buried under a very thick layer, perhaps up to 100 miles of ice. And while this is excellent news if you're on the hunt for potential life in our solar system, for astropointers, it could prove to be a little frustrating. One particularly interesting place to take in is Gipple Katena, a series of impacts that form a straight line across the surface of the moon, stretching 385 miles. This feature was thought to have formed in a similar fashion to Shoemaker Levy 9's impact, with pieces of a broken comet smashing in to the Callisto surface. Despite being so heavily impacted over the eons, Callisto's craters are different than others that we've seen so far. It is on this icy moon where we encounter one of the big high-pointing challenges of the Jovian ice moons: permanence of land features, or rather, a lack of it. It has to do with the nature of ice itself. Despite being beyond the frost line, where water retains its solid form, ice is still subject to viscous relaxation. Basically, large objects like craters or mountains slowly flatten and disappear. Ice just doesn't have the overall strength necessary to hold up very heavy objects for sustained periods of time. The best examples of this are palimpsests, a particular type of crater. The word originally was used to describe an ancient piece of parchment where the writing had been scraped off and the parchment reused. But over time, the faint remains of the former writing would reappear, enough that you could still make out the earlier text. On the Jovian Moons, where this occurs, the word is used to describe how the features and ridges of a crater have slowly disappeared over time until all that's left is a remnant or memory of a crater. And this is particularly noticeable on the larger impact sites. Not all is lost, though. And while the crater rims may have flattened, Callisto still has some ridges and scarps, but those too may be a bit of a mirage, subjected to the same viscous relaxation of the craters. But if there is a high point on the planet, then this is likely where it will be found. It's an educated guess, but based on what we have seen on previous worlds, such as Mercury or even our moon, then the edges of craters might be our best chance to find any real height. Ranges created literally by the force of the impact itself. With that in mind, we'll want to explore the two largest craters on the planet, Valhalla and Asgard. Valhalla Crater is found just north of the Callisto equator, on the Jupiter-facing side of the moon. You'd want to take in this crater regardless, as it is the largest multi-ring impact crater yet discovered in our solar system. The rings that surround this crater can actually be broken up into two distinct groups, the outer and the inner. And of the two of them, the inner is where you're going to want to focus your attention, because they are less degraded than the others. That said, this moon here could well be like other places we've already been, where the tallest feature, whether it is a hill or mountain or ridge, isn't necessarily the highest point. Our second location is Asgard Crater. Found west of Valhalla, Asgard is the second largest impact crater on the planet, measuring 1,000 miles in diameter. Of particular interest will be the Doe Crater, a smaller impact site that dominates the center of Asgard. This crater will be worth checking out as it has a dome rising up in the center that may be worth climbing, as it has an estimated height of over 3,000 feet. Before we depart Callisto, there's one last place that you're going to want to visit. And it wouldn't matter if you were a high pointer or not, because this is truly one of the wonders of our solar system, the Ice Spires of Callisto. Southeast of the Asgard Crater, you will find these incredible structures. And they're unique among the Jovian Moons. These icy knobs stand about 260 to 330 feet in height. There are some mysteries surrounding these fascinating features, both in how they formed and how they appear to be eroding, a particularly intriguing element on a supposed dead moon. Regardless, walking amongst these spires shall be a fitting conclusion to our time on Callisto. Moving on from Callisto, we start our journey inwards to Ganymede, the largest moon not only in the Jovian system, but also our solar system. It's among halfway in from Callisto and orbits Jupiter at 665,000 miles. It is the 9th largest object yet discovered in our solar system, and is actually larger than the planet Mercury by 240 more miles in diameter. Ganymede is turning out to be quite the place. It's the only moon in our solar system that has a magnetosphere. On top of that, it's thought to have more water than any place else too. Over half its volume is thought to be H2O. On the flip side though, Ganymede is the largest object in our solar system that doesn't have a substantial atmosphere. Just a very thin layer. As you approach Ganymede, you'll quickly spot one of its most distinctive features, the light and dark sections of terrain that divide up the moon. The dark, older areas cover about 40% of the satellite and have numerous craters. The other 60% is younger surface, lighter in appearance, and is lined with intricate, grooved patterns. The dark terrain also provides some intriguing clues that Ganymede may have suffered a major collision at some point in its history. An object about 90 miles wide smashed into the moon at a blistering 10 kilometers per second. The end result would be an impact scar with a diameter of 9,600 miles. Truly a world-shaking event. If this were the case, it would be by far the largest identified impact site in our entire solar system. Another thing you'll notice is that Ganymede has aurorae. When you finally get to the surface, you're going to want to spend at least a little bit of time looking up, because you're going to be privy to one of the best light shows around. You can thank the interaction between Ganymedes and Jupiter's magnetic fields for the amazing and bright lights, but it is also a sign of a more pressing concern for prospective explorers and climbers: radiation. Now for the bad news. Ganymede is where we have to start dealing with the biggest challenge in highpointing in the Jovian system: radiation. Yes, Ganymede has a magnetosphere, but it doesn't really do it any good like, say, Earth's protecting us from the sun when you're parked right next door to a colossal gas giant whose magnetosphere quite literally overwhelms yours. Ganymede receives up to 8 rem of radiation a day. And while that might not seem like a lot, to put this in a little bit of perspective, if you go to the beach at the height of summer, you're going to be exposed to 0.14 rem a day. In addition to the radiation, Ganymede's surface also has the same issue Callisto's does with the settling of land features. The ring mountains you would find around craters have flattened over time, but there are still remnants, irregularly shaped massifs scattered about the surface. Once again, astropointers are going to have to do a little bit of exploration and surveying if they want to find the high point. But you do have some leads. Those aforementioned massifs, they're probably a good place to start. Another potential lead is the grooved terrain found in the light sections of the moon. These land features are thought to have been formed as a result of tectonic activity or from water being released from beneath the surface, some reaching as high as 2,000 feet and stretching for thousands of miles. Perhaps the best place to start is in the Irregular region. Images snapped by Galileo of this region revealed the ridges and mountainous terrain throughout. The true height of these features has yet to be determined. The truth is, Ganymede may well be another one of these examples where the tallest mountain isn't necessarily the highest point. And there's one big clue for this here. Like Mars, Ganymede has a bulge. Unlike the Martian Tharsis, though, it's not drastic in elevation. But, that said, it's still significant. Found near the equator, Ganymede's bulge measures about the size of the country of Ecuador. As for height, it rises up approximately 2 miles. The big question, though, is how it got there in the first place. How this feature may have arrived at its present location is still open to debate, but there is a theory, and it involves the nature of ice and the force of gravity. But not gravity from Ganymede. Instead, gravity from Jupiter. Ganymede's tidally locked, meaning the same face always faces the planet. The easiest example of this, of course, is our moon. Now, this ice is thought to have formed on the poles, but because of the relentless power of Jupiter's gravity, it quite literally forced the ice to flow towards the equator and its present location. That said, regardless of how it got there, any land feature with any elevation sitting on top of this has a distinct advantage to being the highest point on Ganymede.